Lesson 12 in our Unit 2 storyline, what technology exists now to allow us to use a form of rocket fuel in a car? So what did we figure out in our last class? Hydrogen takes up less space than gasoline. Burning hydrogen produces water. Hydrogen has a higher energy output per gram. Burning octane produces carbon dioxide emissions. And octane has a higher energy output per mole. Why? Because it has more bonds per particle. So if we're comparing particle to particle, octane has way more bonds, so it ends up way more energy. What might we still be wondering? Why isn't hydrogen fuel used more in cars? And how is a rocket engine different from a car engine? So what is different about hydrogen fuel used in a rocket engine and octane used in a combustion engine? Well, in a rocket, hydrogen and oxygen are not carried as gases. They're supercooled into liquid form, so this helps them take up less space. Gasoline is already in liquid form, so it doesn't need to be supercooled. So that supercooling is definitely energy that has to be exerted. What is different about hydrogen fuel used in a rocket engine and octane used in a combustion engine? Well, in a rocket, when the gases are burned, the steam is pushed through a nozzle, and that pushes the rocket up. But in a car, when the gasoline is burned, the steam pushes a piston up and down to move the car. So remember the 4-stroke engine: intake, fuel, compression, squish it up, power, spark, psh, explosion, exhaust, the gases leave. A hydrogen fuel cell, so look at this. So we have hydrogen fuel and we have oxygen from the air, or if we're talking a rocket, we're talking about oxygen stored in a tank. And then look what's happening here. This looks different, right? Different process. So there are some important differences between these two types of engines. Let's focus on the fuels first. What do we need to consider if we wanted to use hydrogen fuels in our cars? So share some ideas. Well, it seems expensive to keep the hydrogen supercooled as a liquid. We couldn't pump hydrogen as a gas. First of all, it would take up too much space. Also might be more difficult than if we were pumping a liquid. Now, what about the two types of engines? So let's focus on the engines. What do we need to consider about the structures of the engines themselves when we're talking about being able to use hydrogen? Well, a rocket engine uses a nozzle that pushes it forward. A car engine uses pistons. It would be hard to drive a car if the nozzle was pushing it forward all the time. Rockets are expensive. Cars with rocket engines would probably be expensive too. Let's watch a video of a rocket car to see if we're right. Okay, time for you to do some more work. Go to the Schoology folder. Pick one video, 1, 2, 3, or 4. 3 just has 2 versions of it. You may work with your table partner. So you're going to pick a video, and then what? Well, you're going to watch the video. As you watch the video, you're going to fill out that side of your notes about the video. Don't forget to write up here which video you picked. When you complete your notes for the video, go back to that folder in Schoology and choose one of the articles, 1, 2, or 3. Again, recording which article you picked, and complete the notes column for that. Again, you may work with your table partner. Okay, now let's share some ideas. You looked at a video and you looked at an article. What did you learn about hydrogen fuel in cars, hydrogen fuel in other vehicles, and hydrogen fuel cells? So tell me something that you learned. Let's review some of the key ideas and add these to your notes. Cars using hydrogen fuel have hydrogen fuel cells. Hydrogen fuel cell does not use combustion. It uses a chemical reaction. It's more like a battery. Hydrogen fuel cells are very different. They use a chemical reaction to move electrons and produce electricity, not combustion, not burning. So what did we learn today? We learned that cars using hydrogen fuel use a different type of engine, completely different. This engine uses a chemical reaction to produce electricity instead of combustion. It's more like a battery. So what do we still need to know? Where does hydrogen fuel come from? And why is hydrogen fuel so expensive? We're going to have to find out.